Hi, it's Jan Beta and I'm going to continue working on the Amiga 3000T that I started the restoration process on in the previous episode. We found a huge mainboard which is sitting next to me here. We found several expansion cards, most notably a A2386 bridgeboard. And both the bridgeboard and the mainboard had leaky batteries on them, so we removed them, and today's episode is going to be mostly removing the battery leakage, neutralizing it, and seeing if the damage that it already did can be fixed up. And if everything goes according to plan, we might even have a booting Amiga 3000T board when this episode ends. We'll see. Stay tuned. So this is where we're at. If you want to follow this project in full, the links to all the episodes I am going to make and I already made are going to be in the video description for all of these episodes. So you can watch this from the beginning if you want. This is just the second video. We just got to removing the mainboard from the chassis and we removed the battery, which was a GP brand, which, as I've heard, tend to leak a bit less than the Vartas that were on some of these. So the battery corrosion seems to be relatively minor, but there might still be some compromised traces and such. The battery was sitting here and the battery leakage, this board sits upright like this, and the battery leakage, of course, flowed down all the way here. And in the last episode I pointed out that the leakage would be mostly here. But as this was probably flowing down, there are some green pins on this logic chip and also on this one and on this one. And some green flakes on these oscillators here as well. But I can't see any corrosion from here, basically. So half of the board, this region here, we're going to have to inspect very closely and do some restoration work on it, likely. So that's what we're going to do. This is where the battery was, and I managed to remove it pretty cleanly, but the negative connection here is a bit corroded, so I wasn't able to remove the solder from that fully. We're going to take another look at that. Unfortunately, there are a lot of traces running under the battery here, I think from the kickstart ROMs mostly. So that might be a bit tricky to see which ones are broken, but we're going to clean this up as well as we can. And also this coprocessor 68882, that's pretty compromised. It seems there are several green pins on this side and on this side. This chip also is a little logic chip that's also a bit compromised. And the capacitors here also have a bit dull solder joints and also some chips down the line. So that's the damage that's visible so far on the front side, and on the back side of the board you can see from this angle, here's where the battery was, the contacts with some flux residue that I caused while desoldering it. There are some dull spots here, pretty much the same as on the front side. I can't see any damaged traces here around the battery yet, but we're going to have a closer look at that. And of course we are going to have to neutralize the battery leakage on this side as well. You can see these dull spots here. That's where some of that accumulated, it seems. Thankfully, it seems nothing got further than this point here on the back side. So some of it seeped through the vias there, but not much, it seems. We're still going to clean the whole board, of course, and I have some tricks up my sleeve that hopefully work in this case. Yeah, let's see. So first order of operations, I should have probably done this before I even pointed at the board. I'm going to put on some gloves because this stuff is pretty nasty and not very healthy. So we are going to have to protect ourselves. You don't, you're just watching this video. No battery leakage on your end. But yeah, these batteries usually contain cadmium, which is pretty unhealthy. So just taking some precautions here. And also some of the chemicals I'm working with are not really great for the skin. We are going to neutralize what's left of the leakage first. And we're going to start, I think, with the top side, because this is where the battery was. I am going to remove the kickstart ROMs, these two here. These are version 2.04, which was the version that was the most recent one when this was released. And this is ROM 0 on the left from this angle and ROM 1. So we are going to extract these carefully. And put them aside and take a look at the sockets and the traces underneath. Looking quite good, actually. So there's no corrosion on these contacts as far as I can see, and also the traces that I can see are intact. But this is also not in the region that the leakage would occur if this was stored upright. And it seems to have been stored with this being the upside of the circuit board, so all the leakage went down here this way. We don't have any corrosion on these sockets, so we probably don't even have to remove them. I'm still going to clean the area here. There are some vias that look a bit compromised. Yeah, what I like to do is use white vinegar, because the battery leakage, usually the battery juice is referred to as an acid, which it isn't. In this case, it's basic, and we can neutralize it with using some acidic chemical. In this case, I'm going to use vinegar. This is just standard white vinegar that I got from my kitchen. I'm going to use that. It's, I think, 5% acidic, and you don't want to go wild on the acid contents of this, because you are damaging the metal parts of this, of course, with any acid that is more aggressive than that. We're going to put some vinegar here and neutralize the basic battery leakage. That's the first step, and I'm going to carefully try to put some under this chip, the coprocessor, because I don't really want to desolder that. It's a PLCC package and it's not really easy to desolder these, so if we don't have to, I would prefer not to desolder that, but it would probably make sense to get that out, because the leakage probably got under there. We're going to try to get some vinegar under there to at least neutralize the basic leakage there and to stop it from further corroding. And of course you want to remove the vinegar afterwards, because that is going to cause more corrosion from the other side of the chemical spectrum in the longer run. So we're going to put some vinegar on here, on all the parts that I can get to, and remove as much of the corrosion as we can, and hopefully neutralize the battery leakage in the process. And then remove the vinegar with some distilled water, some isopropanol, my favorite, and some Contact LR is a cleaner for PCBs. This stuff is really good. So yeah, that should hopefully solve the problem of this getting eaten away any further. Yeah, let's start the process, I guess. I'm going to use Q-tips, and I also have a syringe here that I can hopefully put some under this chip. I'm going to probably angle this a bit in the process and try to get to every little spot that I can see has leakage on it. And we're going to clean the area with this contact cleaner. A wider area of this board we're going to clean with this after the fact, in case there is some more battery leakage there. Thankfully the whole board looks like it's been clear coated. So there's a green layer of solar mask and then there's a clear coat, it seems. And that prevented more damage, I guess. Looks very, very solid, this board. Very well made. So let's see what we can do. First step, vinegar. Both the top side and the bottom side. Getting some Q-tips out here. Just going to take a look at these chips. They seem absolutely pristine, so nothing leaked into those sockets there, thankfully. Let's see what we can do. I'm just going to put some vinegar in here and use some Q-tips around the components. So let's see. And maybe this is just surface corrosion. Yeah, there's a lot coming off there. That is pretty nice. There seem to be some traces and some of the silk screen is rubbing off. Some damage traces, but most of the green stuff instantly comes off, it seems. That is a very good sign. So the corrosion didn't go very deep. And I also want to get some under some of these chips. I can actually remove the clock chip here. That's this recode chip here. I think I can pull that out and take a look. It does look intact and there's no green spots on the socket. So that's good. We don't have any corrosion here except for on this little logic chip. I'm just going to fill my syringe here and get some under that coprocessor. Let's see. So, channeling Dr. House. Don't try this at home. Just going to go in here. And yeah, that actually works pretty well. I'm going to angle the board so we can let it flow in the direction the battery leakage actually went. And get under there. Yeah, that actually looks pretty good. Going from all sides here. It's of course a bit messy. And we're going to have to remove this thoroughly afterwards. But yeah, this seems to have at least put some under there. And same with these chips here. That's much easier on these larger chips. There we go. This one here. That actually is quite effective, it seems. Sorry, you can't see anything. So the plan is to get under these chips, and actually this seems to work pretty well, because, yeah, I go in from one side here, and it actually gets to the other side of the chips. This seems to be a good way of doing this. I'm going to remove some of the vinegar with some tissue here. And we're going to do the same on the other side of the board. And you don't have to leave this on there for long, really, to neutralize the acid, the basic battery stuff. And in fact, you don't want to use it for long, leave it on there for long. And you want to clean it meticulously because, as I said, otherwise the corrosion is going to continue from the other end of the chemical spectrum. So let's do the same on the other side of the board, basically. So there we go. Going to get some Q-tips ready here. And starting at the battery here. And the surrounding components. And everything in between. And as I said, there are some dull spots where you can see and this stuff went. So I'm going to try to catch all of those. There are some green spots. And I think we have might have some trace damage here. We're going to take a closer look there. Yeah, I think that basically might be it. And we're going to wash it off in a quite similar way. Let's use some distilled water to get the vinegar out there. And you want to use distilled water for this because you don't want anything to conduct, of course. So I'm going to flip this on the side, I guess. Just put some distilled water on here and kind of let it flow. And this is of course going to be cleaned more. Deeper cleaning. This is just to get rid of the initial layer of vinegar here. And this should not corrode this any further. Yeah, that looks good. More rinsing with some alcohol here. And also gets under the chips, I think, if we just let it flow. And I'm going to start the ventilation and air filters, I guess. Yeah, the alcohol should displace the water quite effectively. And the water should have displaced the vinegar. I'm still going to go in with the contact LR, the contact cleaner, the circuit board cleaner. But I'm going to let this dry for a bit so we can see better before I continue filming. It's quite difficult to film it in this upright position anyway, because it's pretty large, tall. At this point, let me take a couple of seconds to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs of all kinds. They currently have their traditional Christmas celebration going on, so there's a lot of coupons and a lot of discounts, including getting free upgrades for funky solder mask colors and things like that. So if you need to get a circuit board made, now is a good time to head on over to the link in the video description, PCBWay.com, and have them produce your circuit boards. Back to the Amiga. So as I said, we're going to finish off with this stuff here. Kontakt LR, Leiterplattenreiniger. German product, but you can get similar products from elsewhere, I suppose. This is really effective in cleaning off flux residue and all kinds of contaminants from circuit boards without damaging the components or the circuit board. So that's kind of the best apart from an ultrasonic cleaner for getting contaminants off of circuit boards, I guess. So I'm just going to do basically the same and angle this while doing it so it can flow under the chips to some extent. Just going to give the whole area another good wipe here. Trying not to damage any of the stickers, which is also, of course, on a machine that's historically as important as this. You don't want to necessarily go overboard with cleaning. And same on the backside. Yeah, this stuff is pretty nasty, so I'm going to stop filming and turn on the air filter now. And then we're going to let that dry. And we're going to do some more cleaning off camera, I guess. We're going to let that dry in an upright position so it can flow to the bottom of the board. And I'm going to be right back. Ugh. So I got another kitchen item out here, toothpicks, because I want to get into some of those vias a bit more and clean out the gunk from them. They do look a bit corroded. Some of these on the back particularly. I just want to get my cleaning agents in there, which I think this is a good way of doing. So I gave it a few more rounds of scrubbing and a bit of time to dry, and it actually looks really clean now, and I hope it is clean enough for me to work on this a bit further. And the corrosion actually doesn't look that bad. Let me zoom in a bit. So there are some vias that look a bit compromised. I'm going to have to work on those a bit, and yeah, the traces actually look intact, at least on this side. On the other side of the board, it looks pretty similar. There's some corrosion going on directly where the leakage appeared, and there are a lot of traces there, so might have to look at that a bit more. And some of the vias here look a bit compromised, but I cleaned up the chips, and except for the pins being a bit dull, I can't see any real damage to them, thankfully. So chances are this is going to be all right. And as far as I can see, there are not many traces under here actually. Most of the connections are directly on top here. Maybe we're going to be good. I don't know. I can't tell yet. And we're going to look at this under the microscope and freeze some of the corroded stuff and patch it up if necessary in a bit. I am going to clean the PC bridge board now, and also the little hard disk controller board that we've seen in the last video that had signs of corrosion. While I have the vinegar out, I'm just going to do pretty much the same process on those. So this is our bridge board. Minor damage as far as I can see on this one as well. In this area where the battery was that we already removed in the last video. Yeah, some green spots here. There are some green spots here, I think. I don't know how that happened. This chip looks a bit compromised. This chip looks a bit compromised. So probably the leakage seeped over the board. Maybe this is from the leakage from the mainboard battery. Maybe that landed on this board. I'm not sure. This was sitting in the bottom of the machine and the mainboard was here basically. So might very well be that that dropped on there in this area. And thankfully it didn't hit the mainboard, but it did some damage here. So we are going to do basically the same here. Some vinegar, leave it on there for a bit. Backside of the board looks completely intact as far as I can see. Yeah, we're just going to put some vinegar on the spots that I can see and then clean it up with some circuit board cleaner, distilled water. The same procedure basically, and hopefully we're going to end up with just as nice a board as with the main board. Maybe we can make this work again as well. And I'm going to do the same trick with the syringe on this one, because that worked rather well actually. Actually quite useful. Just trying this because I thought it would be a good idea. And you know what? It works pretty well to get this stuff under the chips. So yeah, same procedure. Just putting some under the chips here. Yep, definitely works. Doesn't seem to be much corrosion going on at all. And the only thing that's really corroded in the battery area is the Western Digital chip here. That is a floppy disk drive controller, I think. Not sure if this has a hard disk controller on board, but it definitely has a floppy disk controller. I think it also might have a hard disk controller. There's definitely enough connectors going on here. But I think these are 34-pin connectors for disk drives and not hard disk drives. Just going to let this soak in vinegar for a bit. And yeah. And we're going to do the other board as well, simultaneously basically. This is our floppy disk drive and hard disk controller and COM port PC card. And I'm going to remove this LED construction here that doesn't look super professional. I guess it worked, but I'm probably going to build something myself that's a bit more elegant. I have the means to do that. Yeah, we're going to do some cleanup here as well, because some corrosion appears to be... Yeah, there's at least a drop of corrosion that landed on this board as well. It's mostly dusty, I think, really, but here's some corrosion on this surface mount chip, UMC chip. Not quite sure what these are, controllers of some description. Just going to put some on there. And on these ports, there's quite a bit. I'm just going to go over those with the Q-tip, I guess, or with the brush. Yeah, it's not that bad, really. And this connector here looks a bit more compromised, probably because there was nothing connected to it. Yeah, we definitely should use a brush for this. Doesn't have any signs of corrosion in the back. Yeah, the contacts look pretty bad here. Yeah, I'm going to put some vinegar on that anyway. Just in case, we're going to wash it away in a second as well. So yeah, that's the next step. Let's wash these a bit. Yeah, same thing. Distilled water, alcohol, circuit board cleaner, and a lot of scrubbing. And some circuit board cleaner. Yeah. Those contacts look strange. Why are they so corroded? They're gold plated. Yeah, I'm going to have to clean up the mess, but that's basically that. So, a significant amount of scrubbing later. And yeah, both of these cards turned out pretty clean. We have some delamination of these contact fingers on this one. But this is the one I'm least worried about because it is quite easily replaceable. It's a combined input-output like COM ports and hard disk controller and floppy disk controller card for ISA 16-bit PCs. Yeah, some of these contacts have corroded tiny little bit, but it should still be enough meat to make good contact with the socket, I think. And this is not the highest quality, it seems, just ripped off the board here in this part. Yeah, it just completely came loose by just touching it, basically. Yeah, but that's not connected on this side, and on the other side it isn't as well. So this should still work. I think the ones with the connections actually look reasonably good, except for in this area here. This seems to be corroded on the edge, but the contact is usually kind of in the center, so this might still work. And as I said, I'm not too worried about this card. The PC card, on the other hand, turned out pretty nicely. There is some corrosion going on around this little capacitor, so we might have to replace that and remove some of the solder mask to be able to see this area a bit better. But the chip cleaned up nicely. That was the one I was most worried about, and so did the other two chips that had corrosion on them. The connections all look pristine, also on the back side. And this is the point where the battery was from the back side. There's also nothing to see here, but I wasn't worried too much about the back side of this board. So this might also just work. We're going to have to do some more inspections on this, but we're going to focus on the main board in this episode. So this might be tried and repaired if needed in one of the next episodes. Let's see if we can get this Amiga to work and worry about the PC side of things a bit later. Because the Amiga is more important, even though it's DOS-Sember. So this is my contribution to DOS-Sember. A bridge board that I don't even know if it works yet, but we're going to find out probably next month. We'll see. So the next step is going to be assessing the damage and hopefully repairing it. And for that I'm using my digital microscope here, the Tomlov that I've made a whole video about if you're interested. And I'm going to capture the video from this so you can see what I am seeing, and we're going to see what we can see together. So zooming in. So of course I'm going to be as careful as I can, but I think we're going to have to remove some of the remaining battery leakage from this area here where it actually leaked. The rest, there is some residue here and things like that that we need to probably clean up a bit. But it looks relatively clean now, even under the microscope, which is pretty revealing. We have some corrosion going on some of the pins on our FPU here, but it's super minor. This is some of the vias. We're going to have to check for continuity there, I guess, and scrape off some of the remaining corrosion, because otherwise it might corrode further. These traces here look good so far, except for some corrosion that's going on here, I think, under the solder mask. So we're going to have to scrape away the solder mask and clean off that. And yeah, in the whole area basically around where the negative of the battery was, where it actually leaked. Looks a bit compromised. Very little actual damage, it seems. Don't even think this trace here, which seems to be the most corroded one, is actually broken. I'm not sure about that, but we're going to find out. But you can see I'm not even applying any force here. We can just scrub off the solder mask here. And yeah, I think I'm going to go in with the glass fiber pen. This is compromised. You can see the bare copper there, of course, because yeah, it's only protected by the solder mask. I think what I'm going to try to do is to remove the solder mask in this area and also on the traces that I can see here. And here maybe there's a little bit of corrosion here. Yeah, it's pretty minor. Maybe we can get away with just lightly scraping that off like this with my tweezers. But yeah, there's very little damage actually, it seems, but a lot of corroded stuff that we should remove before we go on. I'm going to be as careful as I can, I guess. Let's look at the back side of the board, the bottom side. I think the corrosion there is a bit more severe, but not much. Yeah, some spots here look compromised, like here and here. And this is where the actual battery was, I think. Yeah, these are the battery holes, and there you can see that some of these traces here are a bit compromised. And we're going to have to remove the solder mask there and remove the remaining corrosion, I guess. Yeah, I'm going to see if these traces are actually good and remove the solder mask where it is compromised and clean off the remaining corrosion as well as I can. I think I'm going to start with the top side here, because that's a bit more severe. We are definitely going to have to clean up this spot here. That is a lot of corrosion in there. So yeah, let's do that. And I'm probably not going to talk so much during this process because there's not a lot to talk about. I'm just going to carefully remove the solder mask where it is compromised and remove the remaining corrosion there. And I'm going to try to remove the remaining solder from the battery as well, from the terminal there. So that's my glass fiber pen. Okay, these traces actually look pretty much intact, thankfully. The ones that we just freed up here. And you want to get rid of all the corrosion basically, so it's a bit of work, but we're going to get there. Yeah, that actually looks pretty good already. So did we have some other stuff here? Yeah, Some compromised stuff. Nothing major here. Just a tiny little bit. The ones I was worried about the most, basically. These traces actually look pretty good. Let's try and remove the solder now that we scraped off some of the corrosion at least. Don't know if it was enough, but we're going to find out. And we're going to have to do some more cleaning and things like that afterwards, of course. Yeah, that's much better than it was. Okay, let's see if we can get that out, because we want at least the possibility of a new battery in there at some point. Probably not today, but at some point. Yeah. That looks pretty neat. Okay. It doesn't really look neat because it's so corroded, but looks like we got the solder out at least. Yeah, that looks good. Okay. These ones here. And there's still enough copper to make a connection there. That is great. So it looks like we don't have any super major damage here, really, to the traces. Can't see any damage at this point. Yeah, this needs a bit more cleaning, of course. This part was the worst, of course, around the battery terminals. And cleaned up super nicely, really. Here that we need to clean up a bit more. But even that connection appears to be still intact, judging by how the trace is visible. Yeah, looking good so far. Let's see on the backside if we have any broken traces there. Maybe this just works. And here we are on the backside of the board. As I said, there's a bit more to do here, but we're just going to do the same here, I guess. Just removing what's corroded and try to not damage the rest of it. Don't think we have any really broken trays. Might be that there's something underneath a chip or something. But this is looking very promising. So I'm just going to do some more cleaning up of this, cleaning off the glass fibers and such. And we might just be able to take this for a spin and try to power it on, actually. Yeah, I'm going to check continuity on these, the ones that I saw that are corroded and that I freed from corrosion at this point. Yeah, and we're just going to see what happens. Yeah, this process can take like hours, of course, because you always find more corroded parts and you ideally get rid of all of it. But at least from this close-up inspection, it looks like no traces were harmed. They were harmed, but they were not broken. So that's good. Yeah, I'm just going to go in with my multimeter now and check some of the connections that looked compromised. It's a good idea to not only visually check them, I guess. So there are some connections that are supposed to go to this chip here, of course. And there might still be broken connections from the little vias to the chip. So I'm just checking each one. They're all on the side of the chip, so that's pretty easy to see, actually. Yeah, this one. This one also has a connection, that's good. Some of the pins are connected to one voltage rail or grounds, so there's a bit more current carrying capability, I guess. Where does that one go? This should just be ground, yeah. This one looks a bit compromised, should go here, yes. Yeah, it's all looking pretty good, actually. Yeah, that's looking really good. Let's check the backside quickly. There are some traces that looked a bit more compromised here. So this one, yep. Just following these by eye, basically. And that works relatively well for a circuit board like this. Yep, these are all the traces here. This one goes over here somewhere. This one might be broken. I think we might have found one broken one. The via is too corroded to make contact. Yeah, this one, that's one that's under the chip, actually. That's not good. Okay, I think I found one broken connection here. That is this one. You can see that there's absolutely no copper in this via. That's all corroded away, I think. Yeah, that one's broken. So we're going to have to figure out where that one is supposed to go. Yeah, I'm going to have to do that with the camera out of the way, I guess. So yeah, I'm not sure where this connects to, but we are going to find out. And it goes over here, here, and lands here. Let's see if that's correct. With the remaining copper there. Yep, I followed it correctly. So that's where this is supposed to land, but I'm not sure where this came from the top side. It's under the chip. We can use schematics. We don't necessarily have to remove the chip, but that's an option at least to desolder the FPU. I don't want to do that unless I have to. So we have our broken connection figured out on this end, so we can look it up in the schematics. That's U712. Pin 1, 2, 3, 4, 5, 6 of this U712 MC74F32. I'm going to have to look that up in the schematics. That I'm also going to link in the video description, of course. And I think that might be the only connection that's broken, but we're of course going to continue looking for more broken connections. We are going to have to figure out where this one is supposed to land on the other end. So yeah, let's see if we can figure that out. Yeah, sorry about the non-screen capture here, but these are the schematics that I just loaded up and searched for U712, U712, and pin 6 is actually supposed to go to the FPU reset line. And that broken connection makes our whole FPU not start up or not be initialized properly. It's also connected here through this 7407 to the CPU reset, and then further down to the general reset. So this is one of the main like crossing for reset signals, it seems. Yeah, we need to put the FPU reset signal back where it belongs, I guess. And I guess it belongs on the FPU, but let's search for that. Just going to search for FPU reset here. That goes to pin 13 on our U101 which is our 68882 in this case. This schematics have 81 in there, that is the predecessor basically, but it's pin compatible and the 82 can do higher clock speeds and things like that. Just another version basically of the same chip. So pin 13 is where it's supposed to go. So let's see if it goes there. So these PLCC packaged chips have a pin 1 marker that is a little dot on one of the sides here, and that's pin 1 actually. And from pin 1 we're counting down this side like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is the one on the side here. So 11, 12, 13. That's where our reset pin is. And that's where our reset signal should go. Okay. Interestingly. Oh, this is probably ground. Oh, that's the voltage supply. Okay. So, yeah, one connection to this chip is also present on this chip, and that's VCC. And it seems we have a short here. Yeah, there shouldn't be so many connections to VCC, I guess. Let's see if we can fix that. So we are going to have to clean up those vias, I guess. Something seems to be shorting out our voltage supply there. Yeah, we have a general short to ground in this area, I think. So VCC is shorted to ground, and that's not good. I think it's something to do with the vias, because this is a 4-layer board, and there are ground layers and VCC layers in between these layers that have the actual connections on them, and things are connected there in different layers through these vias. So we might have to clean these vias a bit more. They're so tiny that I don't have anything that I can get in there with, really. We'll see. I'm just going to search for a small component that I can possibly push the dirt out of there. Maybe there's some copper residue from my scraping in there. We'll see. Okay, these cheap resistors that I have seem to be just the correct size. Let's see if we can clear up some of these. It might be the chip that's shorted out. It might be something wrong with the vias. Usually these vias, yeah, I think most of them are pretty cut out, so they shouldn't short out between the layers that they are not supposed to connect to, I guess. Maybe we are going to have to get into more intricate business here. I was hoping that this would be it, basically. I did some more work off camera and cleaned out the vias completely. There was some corroded stuff stuck in there. I used a little resistor lag which fit the vias, and I was carefully pushing the stuff out, which worked reasonably well. And I did some more measurements, and unfortunately we have a nearly dead short on the whole 5-volt rail that supplies the chips with its voltage. Let me show you. I'm measuring directly at the power connector now. This is 5 volts, 5 volts, 5 volts, some ground pins and the rest of the voltages on the other pins and the tick signal and such. But yeah, this is basically what we get on the 5-volt rail. That's 8.6 ohms roughly on the power connector. So that's what the power supply is going to see. And of course that applies to everywhere else on the board as well. That's nearly the same everywhere except for some graphics circuitry and the battery circuit. Every single capacitor on this board the electrolytic ones and the ceramic ones just show me roughly the same picture here. And that might have a lot of causes, actually. Might just be one of the capacitors somewhere that is decoupling the 5-volt line on the board. But of course, in this scenario, it is likely that something's wrong in this area here. It might, of course, be something else entirely. And given that it's not a dead short, we still had some resistance there. Maybe this would even power on like this. It is likely that something's wrong, though. Probably my guess would be that one of these capacitors in this area, the little ceramic yellow ones or the electrolytic ones, got so corroded that it shorts out, or the FPU itself. It was pretty corroded on the pins, even though it looks relatively clean now. But there might have been some corrosion that seeped in there. And this has multiple ground pins and voltage supply pins around the whole chip. So maybe something got eaten away internally because the corrosion crept inside. That would definitely be enough to cause something like the 8 ohms resistance across the board here, I think. I don't have the necessary tools to remove this chip yet, but what I can try to do is to lift at least one of the legs of these capacitors and see if that changes anything, which would of course be the best case scenario because these are very easy to replace. These are still obtainable, and I think there's a jumper somewhere where you can disengage the FPU altogether, so that would be an option in case this is really broken, but we don't even know yet. I think the way forward is to try the capacitors at first, because that would be one of the likely scenarios, and it should be relatively easy to at least lift one leg of these. Maybe remove them altogether, because they need replaced in the longer run anyway. Yeah, I think that's what I'm going to try. I'm going to lift the capacitor legs and see if that clears up our short, or our near short. It's definitely too low resistance on the 5-volt rail, as far as I know. I've obviously never worked on one of these, but on another Amiga I would be very suspicious about that. Yeah, let's lift some capacitor legs here. I don't have very high hopes for this, but it's at least worth a shot, and it's something that I can try with the means available to me. More on that later, I guess. There's of course a lot of corrosion on the solder here. There we go. Okay. Lifted the positive side of the leg. Let's see if we have our short still. Yep. Exactly the same. Yeah, so it wasn't this capacitor. That's what we know at this point. Let's try lifting the other one here, which wasn't as corroded. There we go. That was much easier because there was less corrosion on there. Yeah, my money is on the chip, really. Unfortunately. Yep. Yeah. So we still have 8.6 or 8.5 ohms resistance on the 5-volt rail. And yeah, there's some corrosion visible here that we need to clean up, so we're going to have to remove this resistor anyway. And I'm probably going to remove the whole chip because I don't know what's going on below this, and there is very likely some corrosion, potentially even corrosion that ate through the layers of the board and shorted out the ground plane with the 5-volt plane. I'm not sure if that is possible because the lacquer seems to be really solid, but there was a lot of corrosion around all these pins here, so there probably was a lot of leakage going on and accumulating under this chip. However, I don't have the tools I want. I have a hot air station, but I kind of want to try to remove this with low melt solder, which I don't have, which should be the least destructive way to approach this, I guess. Of course, it might be something entirely different, one of the other custom chips or something like that. So it would be a good idea to pull all the chips and check the voltage rail one by one, basically. Might be multiple faults, might be any of these RAM chips, of course. They all feed from the same 5-volt rail. But given that this displayed a yellow screen, it is likely that this chip is just not working correctly. I think that's one of the symptoms that this would cause. Yeah, as I said, I could try powering this up. Probably it wouldn't do any damage, but I'd rather not. Yeah, unfortunately, that's where we're going to have to end this episode, I'm afraid. Because, as I said, I don't have the low melt solder that is probably the best way to do this. If you know the resistance on a 5-volt rail that is normal, I would guess it's much, much higher than 8.5 or 8.6 ohms. Let me know in the comments. Yeah, very unfortunate. It didn't look like much damage was done, but I think this might be an indication that there is more damage indeed. And I don't think I caused it. You saw the pictures from the microscope. I don't think I shorted something out there with removing the corrosion. The traces still look separate enough. But it might very well be that there's something shorted internally in this chip or somewhere else on the boards. We're going to figure that out after I get the correct tools for that, hopefully. Yeah, bit of a disappointment. I planned on at least playing some Turrican on this, which of course is not very appropriate for a machine like this, but it's tradition on this channel. But yeah, that's where we are. Hope you understand I'm not going to try to power this with the power supply at this point. I might go in with a current limited power source at some point. That's another idea, and then look for heat spots on the board. That would be a classic way of figuring out where the short actually is. But yeah, at this point, I'm just going to call it and continue this in the next episode. There might be 1, 2, 3 videos in between before I get the tools that I need, and I'm probably also going to try to find a replacement 68882, 25 megahertz. If you have one spare, feel free to contact me. I'm not sure how available these are and how good the ones are that are available, if they are at all available at this point. Yeah. That's it for today. Thank you so much for your time. Special thanks, as always, to everybody who supports me on Patreon and on Ko-fi and on the YouTube channel memberships page and elsewhere. The links are on my website and in the video description. Please remember to subscribe to this channel if you are not a subscriber, because this series is definitely going to continue. I don't know exactly when, but I'm going to work on this a lot more in the future. So yeah, hopefully see you around at some point. As I said, the next videos are going to be unrelated to this. There is going to be one more video this year, but no videos before Christmas, I guess. So happy holidays, happy Christmas if you are celebrating these things, and see you close to the end of 2025 for the last episode of this year. Time flies. That's it. I'm Jan Beta. See you next time. Bye.